Hi, welcome to my video on Aromatic Series. Aromatic Series, we're going to look and derive the formula for an aromatic series first. And again, series means the sum of the terms of a sequence. So let's look at trying to derive the formula. Let's look at the numbers of the sequence 1, 2, 3, 4, 5. And the average is the sum divided by the number. So the average is 1 plus 2 plus 3 plus 4 plus 5 divided by the number 1, 2, 3, 4, 5. And that gives us the sum is 15. If you add them all up, you get 15, 5, 9, 12, 14, 15 divided by 5, and the average is 3. So if we take the numbers 1 plus 5, and we take the numbers 2 plus 4, and we take the number 3, we notice that the numbers add up to 6, and that's just a 3. And the 6 is 2 times 3, and this 6 is 2 times 3, and we have a 3. And you notice that we have 1, 2, 3, 4, 5. We have 5 3s. Notice that the average is 3, and we have 5 of them. So that means we can take the 3 and express it as a 1 plus 5 divided by 2, because it's the average. The 3 is the average. So that means that, notice that the 1 is the T1 and the 5 is the T5 or the Tn. So we could have 5 times T1 plus Tn divided by 2. And we can call the 5, let's make that 5 at the nth term. Make that an n. So what I'm doing is trying to explain deriving the formula for you in a simpler way. And let's do that with this series, 2, 6, 10, 14. The average is the sum of the numbers divided by the number of numbers. So the sum, 2 plus 6 plus 10 plus 14 divided by the number, which is 4. And that sum adds up to 32 divided by 4. So that's a 24, 30, 32. And the average is 8. So let's look at 2 plus 14 and 6 plus 10. 2 plus 14 is 16. I said a 10, wrote down an 18. 6 plus 10 is 16. And notice that 16 is 2 times 8. 16 is 2 times 8. And notice the average is 8. So we have 2 8s here, 2 8s here. So we have 4 times 8, which is 4 times the average. And again, the average could be calculated as 2 plus 14 divided by 2. And that's the same as n, 4 is the number, times 2 is the T1, 14 is the Tn, and divided by 2. So notice I derived the equation by finding the average, because the average, really these two numbers added here, the first and the last, divided by 2 is the average of all the numbers divided by n. So the formula for formula for aromatic series means add. The formula is n times t plus 1, t plus 1, t plus n divided by 2. Or we can also sometimes I write it down as n over 2 times t1 plus tn. And this is a formula that I memorized for the sum of an arithmetic sequence. So if you memorize this formula, again, it's the number that's in the sequence divided by 2 and the first and the last terms added together. So let's find the sum of these numbers by using the formula. Now it's easy to add these up to get the sum, but the formula is Sn equals n divided by 2 t1 plus tn. And we have the sum of 1, 2, 3, 4, 5, 6. So it's the sum of 6 terms. 6 is n. The first term is 1. And the tn term is the last term, which is the 6th term. That's t6, which is 11. And that gives us 6 divided by 2 is 3. 1 plus 11 is 12. And it gives us a sum of 36. So if you add these numbers up, you will get a 36. Notice 1 plus 11 is 12. 3 plus 9 is 12. 5 plus 7 is 12. 3 12s is 36. And B, we have a sequence, and the formula for find the sum, Sn, n divided by 2, bracket t1 plus tn. And again, 1, 2, 3, 4, 5, 6, 7. So this is the sum of the 7 terms. So 7 divided by 2, and the first term is 3. The 7th term is 33. And so that's 7 divided by 2. Add these to get 36. And divide 2 into 36 to get an 18. And the sum becomes 7 times 18 is 126. Again, you could add all these up and get the sum of the arithmetic sequence. So the sum of these is called a series. So the Aromatic series this is the formula. Sn equals n over 2 times t1 and tn. So the sum of the S60. Now, notice I have to get the sum of 60 terms. Now, I don't think I would want to work out all 60 terms here by plugging in t1, put in a 1 and get a 7, t2, put in a 2 and get 11, etc., etc., and do that 60 times. So the fast way would be the formula is Sn equals n over 2 t1 plus tn. So that means we need to work out when n is 60. So that's easy, 60 over 2. But we need the t1. We don't. So what we got to do is work out the t1. So t1 is 4 times 1 plus 3. 4 plus 3 is 7. So the first term is 7. Now we got to work out the 60th term. So that's tn. So t60 is 4 times 60 plus 3. That's 240 plus 3. So that's 243. So now we put the 60th term, which is 243, in the brackets. 60 divided by 2 is 30. 243 plus 7 is 250. Now we multiply 30 by 250, either with your pencil or pen, and if you do a calculator, you get 7,500 as the sum of all those terms. So much easier to use the formula when you have a large number of terms. Again, we had to work out the first term. We had to work out the 60th term because that was the first and the last term in the sequence. And the sum works out to be, here's the formula. And what about Tn is negative 3n plus 100. And we got to find S20, the sum of the first 20 terms. Again, the formula, and again, you can pause the video and see if you can write down the formula. And can you write down the formula? Sn equals n over 2 t1 plus tn. There's so many formulas to remember in sequence and series, but you have to learn them, memorize them, and know which to use when. So we're going to get the sum of the 20th term. So n is 20. And again, we need the first term. So t1 is negative 3, 1 plus 100. Negative 3 plus 100 is 97. So we have the 97. And we have to get the tn term. So we have to work out the 20th term, t20. And t20 is negative 3, 20 plus 100. And that's negative 60 plus 100. And that's a 40. So we put the 40 in. Now we work out the equation. 20 divided by 2 is 10. 97 add on 40 is 137. And 10 times 137 is 1,370. Just add on a 0. And again, you have to memorize the formula for the sum of an arithmetic sequence. But you need the first term and the nth term. Now, this one's a little bit different. Find the sum of 1, 6, 11, etc., etc. if we have the last term is 146. So again, we need the sum. So here's the equation. That's the sum of an arithmetic sequence. And how do I know it's arithmetic? Because 1, 6, 11 is the differential. 6 minus 1 is 5. 11 minus 6 is 5. So the D1 is 5. So if the D1 is 5 and is an arithmetic sequence, so now we have to go and work out what T1 is and what Tn is. So we have to get the sum. But we don't know how many terms. So we can fill in. We can't fill in what n is yet. We can fill in what T1 is, which is 1. We can fill in 146, but we can't fill in what n is. So we have to go and solve for n. Let's see. Now we got to go with the equation. The arithmetic sequence is from scratch. Tn is T1 plus n minus 1d, and the last term is 1. Let's see, Tn, let's go with Tn first. T1 is 1 plus n minus 1. The difference is 5. So that's 1 plus 5n minus 5. So that's 5n minus 5. So we have the equation of an arithmetic sequence as an plus b, and now we know that this nth term is 146. 5n minus 5, negative 5n. We're solving it for n, so I'll move the variable to the left side and the constant to the right side. Gives us a negative. What does that give us? 46, 5. Oh, I got careless. 5n. 1 minus 5 is negative 4. And that gives me a negative 150. Divide by negative 5. And I get 30. Now, I have everything filled in for this formula. So, the sum of the 30 terms is 30 divided by 2. The first term is 1. And the last term is 146. So that's 15 times 147. And 15 times 147 is 2,105. You use your calculator or use your pen. So I had T1, one, I had 146 here, but I didn't have n. So I had to derive the equation as Tn is 5n minus 4. And then I put the 146 in, worked out what n was, then I could work out the sum. So the problem is reversing it, working backwards, and that's what happens. In math, you need different types of problems to help you think. Now I have another one arranged here. Let's try this one. For 3 months, which is 12 weeks, Job A pays $5,000 per month with a monthly raise of $400. Job B pays $600 in the first week and $150 weekly raise. Which job is the better job to have, give you the most pay? Well, let's look at Job A. So Job A is only for 3 months. So Job A gets $5,000 in the first month. Then there's a monthly raise of $400. So the next month he's getting his $5,000 plus his $400. And the next month he gets another $400 onto that. So that's $5,800. So the sum of all of those, if you want to add them up, is $16,200. So that's a quick way to do it without using the formula. But if you want to do Job B, let's do Job B down here. Job B is $600 for the first week and $150 weekly. So I got to go for 12 weeks writing all these down. Well, you can do that. I mean, if you want to say $600 in the first week, and then $150 for each week after that, so that's going to be $750. And $150 for the next week would be $900. If you want to continue on like that and add them all up and then see which one is better, but because we have a lot of terms here, so we're working for 12 weeks. So that's the sum of 12. And so let's write down the formula first. Sn equals n T1 plus Tn. And we have 12 weeks, so n is 12. We have to work out the first week is 600, but we don't know what Tn is. So we got to go and work out what Tn is. So some people might say it might be easier if we just kept going with this pattern and add them all up. Well, we need Tn, so we need the equation. So the differential is 150 because you're getting $150 a week. So that means D1, first level difference, is 150. So Tn is T1 plus n minus 1 D. The first term, first pay is 600. N minus 1 times 150. So that's 600 plus 150 n minus 150. So we get 150 n plus 450. And we have it. That's Tn. Now we want to know what pay is on the 12th week. So let's do T12 instead of Tn. So we get 150 times 12 plus 450. And 150 times 12 is 1800 plus 450. And that gives us 2,500. So we put that in the equation because that's the last week's pay. Put in the equation for T12. Notice I had to get the difference. I had to find the equation and then put 12 in for the 12th week to get the final pay. So that's 6, add on, and when we add that up, we get 2850, and 6 times that will give us how much? I use my calculator on that. And 2850 times 6. Oops, I haven't got my calculator on. 2850 times 6. 17,500. 17,100. Where did I get 500 at? So, job B has 17,100. Job A has 16,200. So which job is the better? Job B is better. And if you subtract, job B is better, more pay, better by $900. 900. And again, notice the variation in the problem. I used the equation here. Again, you could accumulate all this, worked it all out like this, adding 150 on each time, then adding them all up. You would have got the 1701. And let's look at another problem. A different type of problem this time. Keep the variation going in your thinking. Here we go. In an arithmetic sequence, T1 is 12, and the sum of 10 terms is 255. Find the equation that represents the arithmetic sequence. Well, we have two types of equations. We have Sn is n over 2 T1 plus Tn. And we also have the equation that we're looking for. But in order to get this equation, I have to use Tn is T1 plus n minus 1 times d. So this equation will, when I have this one, it will work out to give us what this is going to be. But we have to use, we know what T1 is. We can fill that in here. That's 12. But we don't know what our difference is. So let's look at this equation. So S10, and that's a 2. We have T1 is 12, but we don't have Tn. S10, that's the n is 10, but we don't have, so S10 is 255, 5, 12 plus Tn. So looks like we got one unknown in this equation. So we'll keep working this equation to find what Tn is, solving it for Tn. So negative 5 Tn is 60 minus 255. Negative 5 Tn is a negative 195, and divide by negative 5, and Tn, we said Tn, right? Tn comes out to be 39. Use your calculator to divide, and that's a Tn, so that's Tn is that, but that's my 10th term, which is that. So I could have filled, when I put that in, I could have put a 10 right here. I could have put a 10 here, so that's T10. So once I put the 255 in, that wasn't become, that was the 10th term, but I could have put a 10 here instead of the n. So let's put a 10 here. And T10 is 39, then I wouldn't need that step there. So T10 is 39, and now I sub that in here. T10 is 10 minus 1d, but T10 is 39. So I get 10d, or sorry, 9d, that's careless. So negative 9d equals 39 minus 12. So D is, that's plus 12. Gotta be careful. I'm moving the 9D over here to become negative, moving the 39 over here to become a minus. So that's a negative 27. Divide by negative 9. So just be careful. You get a 3. The differential is 3. So that means I have T1 is 12. I have D is 3. So Tn equals T1 plus n minus 1D. So Tn, T1 is 12. N minus 1, D is 3. So Tn is 12 plus 3n minus 3. So Tn is 3n plus 9. And if you put 1 in, you'll get your 12. And if you wanted to work out all the terms, then you can, but this is the equation that represents this arithmetic sequence, which has a first term of 12 and a sum of 355. And if you want to check, the sum is n over 2 T1 plus Tn. Let's see, n is 10. I'm just checking. So I'm doing sum of the first 10 terms. T1 is 12. And the 10th term is 39. So that's a 5 times 41. 51. Well, I can't add now. 12 and 39 is 51. And 5 times 51 is 255. So it makes sense. That's the equation. And that works out to be the sum. I'm just checking the sum here. So but notice again, you have to work backwards, working with the equation and getting the answers. So you're given this bit of information, and one piece is unknown, and you get that. That helps you to work out this equation, which gives you the difference. So a little bit trickier, a little bit heavier to do this equation. This would be like a bonus question or an elite question, a little bit heavy. And it's nice to end it off with a question that makes you think. And if you like my video, click on the like button, subscribe button, visit my website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.